So we shall begin with the national anthem. Please rise.
Bayang magiliw, pero sa silanganan, alam ng puso, sa titik mo'y buhay. Lupang hinirang, tuyat ka ng mag-ibig, sa manlulupig, kita masisingil, sa dagat at bundok, sa simoy at sa langit mo'y kapal. May nilang ang tula at awit sa paglayang minamahal. Ang kislap ng wataw at ngunit ang kumpay na nagdilimig. Ang bituin at araw niya kailan pa may magdidilim. Lupa ng araw ng aming konsepta, ay nalangin sa dilim ko. Aming ligaya na magmay mamapit, at namatay ng dahil sa'yo.
Good morning, everybody. First of all, I'd like to acknowledge the presence of our esteemed President of the University, Alfredo Pascual. Other distinguished members of the faculty and students, good morning. This forum on understanding complex dynamical systems is a first for our university. It's a product of long, hard work and informal conversations that have been going on for quite a long time. Before I introduce the speakers, I'd like to inform everybody that there is live streaming of this forum. And for those who want to log in, I was asked to repeat the website. No, it's www. And then lowercase pregi.net and then /broadcaster. I believe this was already circulated beforehand. And then for those who are watching online, you may text your questions, please, to the following cell phone number: +63 917 668 8425. Okay. Now I have the privilege of introducing the speakers for this morning. The one who will open with his presentation is Professor Nick Poblador, who's a retired professor of management and economics. He'll be followed by our own Vice President, Dr. Giselle Concepcion, who is a professor of the Marine Science Institute and who teaches and does research on bioactive compounds from marine organisms, their cellular and molecular mechanisms of action in relation to human diseases. She's also an academician of the National Academy of Science and Technology and a Scientist 3 awardee of the UP system. The next speaker is Professor Neil Garcia, who is a poet and critic who teaches at the Department of English and Comparative Literature of UP Diliman. He's also a fellow for poetry in the UP Institute for Creative Writing and director of the UP Press. He will be followed by distinguished economist, Professor Ernesto Pernia. He was formerly lead economist at the Asian Development Bank, and he's currently Professor Emeritus. And then last but not least, Dr. Felipe Jocano Jr., who is Assistant Professor at the Department of Anthropology, and his research interests include medical anthropology, anthropological theory, folklore, and the anthropology of religion. So without further ado, I believe in the interest of time, we may ask Professor Nick too. And maybe you could also give a bit more background about the forum, because you were, in a sense, the heart behind this together with Vice President Giselle.
I think the first 2 slides will give some kind of a background of how this forum came about. My name is Nick Poblador, and in my presentation, I'm going to talk about complex systems and complexity theory and what we can possibly learn from this. The purpose of this forum is to come up with a framework, to come up with a transdisciplinary framework for the study of social and institutional change. Framework. By framework, I mean a platform on which we can engage in meaningful dialogue, meaningful conversation, regardless of our fields of specialization. The purpose of this presentation is fourfold, and they are to introduce the basic concepts and principles of complexity theory. Secondly, to identify the elements that are common to all complex systems, be they physical, biological, or social. And thirdly, to explore the impact of developments in information and communication technology on the pace of change of modern society. And finally, to look into what I consider to be a major policy implication from where I sit, of course, and explore these policy implications in relation to changing organizations and institutions, and in particular, changing the University of the Philippines. The following few slides will discuss the distinguishing characteristics of complexity theory. First of all, complexity theory is holistic. Complexity theory looks at the complex system. They are networks of multiple interactive and adaptive components, and they exhibit discernible emergent patterns. But I think earlier, complexity theory is transdisciplinary. Complexity theory goes beyond the boundaries of the traditional disciplines, and therefore, in my thinking, provides a much wider theoretical perspective than our own methodologies and our own theories. Another characteristic of complexity theory is that it looks at the complex system in its totality. It looks at complex systems in their totality and only perfunctorily on their individual components. Of course, I stand corrected here from the biologists and the physicists who might be in this forum. Complexity theory is non-reductionist. Non-reductionist in the sense that the behavior of the system as a whole cannot be inferred directly from individual behavior. Again, I stand corrected here, but there seems to be some ongoing debate on this issue. On the theoretical nature of complexity theory. Complexity theory, unlike most other theories that we are familiar with, especially economic theory, is not intended to be predictive, nor are the conclusions from this theory intended to be empirically verifiable. They are, or for that matter, falsifiable. Complexity theory, from my point of view, provides us with a better understanding of the dynamics of complex systems. By understanding, I mean a discernment of, or having a feel of what's going on in complex systems. Let me say a few more words about the theoretical nature of complexity theory. Reading directly from the... First of all, in conjunction with big data, predictive analytics, computer simulation models, in particular agent-based models, agent-based computer models, and other advanced research procedures, we are now able to establish more precisely the complex interrelationships among the different components of complex systems and to discern patterns as they emerge, However, my position is that we can never predict the state of a system at any point in time in the future. Ontologically, complexity theory is post-positivist. It has its roots in positivism, but it is now interpreted by many, myself included, to be post-positivist, in that it holds that reality, the real world, and the way we perceive the real world are entirely two different things. In other words, there will always be an uncertainty residual in our knowledge of the real world. I stand corrected here, of course. This is a matter of debate, ontological debate. Let me now talk about some common properties that are found in all complex systems. These common characteristics that are found in nature are not just useful metaphors for complex social systems. Rather, they are universal attributes of all complex systems. Now, if there is a single term that encapsulates all of these 5 or 6 characteristics, I will go through these slides in rapid succession so I can catch up with what little time I lost. If there is a single term that encapsulates all of these characteristics, I think it is non-linearity. Non-linearity being the tendency of complex systems to change suddenly, unpredictably, and disproportionately. This throws many of us off from our usual theoretical models of the real world. Well, let me just present some images to illustrate these characteristics. The first characteristic is path dependence. All right, let me go through these images. What we see there is the aftermath of Typhoon Sendong. You all remember Typhoon Sendong of 2 years ago. The picture, the image beside it, shows the path taken by the typhoon. My point in showing this is that had the typhoon 12 hours earlier exhibited fractionally different values of certain variables, such as, for example, surface temperature, barometric pressure, then the typhoon would have veered in some other direction, and that consequence that we have pictured earlier would not have happened. Well, somebody got lost in the jungle. Mountain trekkers like myself sometimes get lost, and the usual reason is that 2 hours earlier we took the wrong path. Oh, we all know what this is. That is a keyboard, and the picture to the left is exactly the same keyboard in the 1911 model of the Remington Rand typewriter. I was trying to remember the phrase dominant design. The design of the keyboard has been the same for the past 120 years. It hasn't changed since then. And they tend to stick. This is the picture of the Lorentz attractor. It is intended to dramatize the fact that in complex systems, any small change in the variable, in any variable, will tend to generate wide variations in the system.